Assalamualaikum, my dear students. I hope all of you are fine and doing well. So the topic that we will discuss today it is the introduction to halides. So the word halide it is basically denoted the group 7A elements in the periodic table, and these group 7A elements are basically known as halogens. So the word halogens is given to the group 7A elements, and these halogens when form the bonding with other elements, then their products are mainly known as the halides. So the definition for the halide, we have a binary compound of a halogen. Binary mean a compound in which we have two atoms of an element. It forms a binary compound with another element or a group. Then their product is known as the halogen or the halides. Next, halide ions are fluoride ions, chloride, bromide, and iodide. Basically, halogens are diatomic particles. They can be written as fluorine, chlorine, bromine, and iodine. On the other hand, when they changes into their ions, then they are called as fluoride, chloride, bromide, and iodide. So we can identify the halide ions. How we can identify the halide ion? By the using of the nitric acid. When it gets react with the nitric acid, then the aqueous silver nitrate AgNO3 solution is formed. So each halide ion gives a specific colored precipitate from it can be easily identified. So this was a simple process of identification of the halide ions. Then we have the classification of the halides. Basically, we have three types of halide ions. Number one, we have ionic halides, covalent halides, and the polymeric halides. All these three types of the halides just depends upon the nature of bonding of the halogen atoms of the halide ions with other elements. It depends upon simple the nature of elements, whether they are sharing their electrons, whether they are losing or gaining the electrons, or whether they are having both the properties of ionic and covalent. Or the polymeric halides may also work as a bridge between the two atoms that are bonded with the halogen atoms. So let's discuss these three types one by one. The first one we have ionic halides. So the word ionic is specifically denoted the ions. We have the simple ions. For example, if we take these group 1A elements, lithium, sodium, potassium, rubidium, and cesium, all these are group 1A elements and these are known as alkali metals. When these alkali metals create the bond with the fluorine, chlorine, bromine, and iodine, then they will be forming an ionic halide. And these ionic halides, if we have lithium fluoride, so bond is very strong, and when the bond is very strong in turn they will have very high melting points as well as high boiling points. On the other hand, these halides have the structure which is three dimensional or 3D, and it is consisting of mainly the ions, and these ions are known as discrete ions. Let's have the name of compound which is the simple. If we have NaCl, this is a sodium chloride and it is also used as table salt. Its melting point is almost 801 degrees Celsius. If its melting point is too much high. On the other, if we have the group 2 element, magnesium, and forming a bond with the chlorine that is halogen, then its melting point is 715 degrees Celsius. So basically, sodium chloride it is purely ionic On the other hand, the magnesium is partially ionic halide. Then we have the third one, which is aluminium chloride. Its melting point is 192, so it is also partially ionic in nature. So this is a simple overview of the ionic halides, that they have high melting points when we move in the periodic table. If we take the examples of the other as the pure ionic compounds, then the fluoride will have the highest lattice energies because fluoride it is small in size as compared to the others, because the atomic number of fluorine is 9, and that of chlorine we have that comes after fluorine, its atomic number is 17. So size of chlorine is larger as compared to the fluorine. So fluoride ion is small in size, so it will have strong energies in the lattice, and their simple trend of decreasing melting point is like this: fluorine is having highest as compared to the chlorine, then we have bromine, and then we have iodine. So this is a simple trend of the energies of these elements. Then we have the second type of the halide, which is the covalent halide. So the halides which are bonded and they are produced just due to the sharing of electrons between the halogens and the other elements, these are known as the covalent halides. So they just make the bond by sharing of the electrons. A very simple example, we have silicon chloride, SiCl4. It consists of molecules, as it is having molecules and highly polar in nature. So the bond between PCl3 and also in S2Cl2, they are polar but less polar as compared to the silicon tetrachloride ion. So that's why as we are moving from left to right, we just move from ionic halides towards the covalent halides. These halides will form the covalent bond with the all elements, and in turn their melting points also decreases as we are moving from left to right in the periodic table, because the intermolecular forces between the covalent halides are weak van der Waals forces. The forces are weak van der Waals forces. So these forces are just here to combine the elements, and that's why covalent halides are present in the form of gas and liquids with the low melting point solids. On the other hand, covalent halides also depends upon their size, and the second is polarizability. The simple size is the size of an atom, the distance between the nucleus to the outermost shell, and the polarizability mean that how much it is having the ability to polarize. So when we move top to bottom from fluorine to iodine, then iodine is having very big size or large in size, and its polarizability is also too much strong. So that's why it is having very high melting and boiling points in the covalent halide. So iodine is most strong covalent halide among all these. Then we have the third type of the halide, it is the polymeric halides. These halides which have polymeric structure and they have partially ionic bonding along with the layer of chain of the lattice. So here we have the polymeric halide which is having beryllium chloride. So it just worked like a bridge between the other atoms, and it is having both the properties of ionic as well as covalent. So that's why they are known as polymeric, because the word poly means many and meric properties. So they can have both the properties of ionic as well as covalent. Then we have the trend in the periodic table. So as we are moving top to bottom, we have here the hydrogen halogen. When the hydrogen combines with the halogen, the bond is the hydrogen bond. First one is HF, then HCl, HBr, and HI. Hydrogen fluoride, chloride, bromide, and iodide. As we are moving top to bottom, their stability is decreases down the group. So the melting points and the boiling points depends upon which type of bond is present, whether it is ionic or it may be the covalent. So all the trends depends upon this property of the elements. So this is the simple overview about today's lecture. I hope you guys understand. And the next topic that we will discuss, it is the hydrides. For that time, you guys have a good day and Allah Hafiz.